Yes, very good afternoon. Let us start with the previously we have covered about the learning from the multiple classes. Yes, Kaushik, are you able to hear me? Okay, Kaushik, if
Yes, sir.
yeah, yeah,
Yes, sir.
Kaushik, if anyone is from the CUHP campus, oh sorry, CU Punjab campus, try to enter into the class. Just please allow him. Fine.
Okay, sure, sir.
Yeah. Okay. Thanks a lot. Yes, let us start with the. We have already covered this part and just go through it. And if there is any problem, then once let me check. Kaushik, are you able to admit or not?
Sir, I think I'm not able.
Oh, okay, okay.
Maybe.
Maybe you don't have any option. Option. Fine, not an issue.
Yes.
I just want to confirm that. Okay. Now let's start with the. Uh, no, there is a little bit updation in the ST2 and the ST1 dates, and your ST1 will be conducted on 25th to 28th July around this, and exact date will be circulated on your Google Classroom. And but tentative dates are there, and your first ST will conduct on 25th July or to 27th July around, and your ST2 will be conducted on the 18th of August to 21st of August, and your interim examination will conduct on 25th of August. There is a tentative dates, and your exact dates will be informed to you by Google Classroom. Now we have get some extra time to cover the topics or to get the more information about the topics. So if you previously we have covered the in the last lecture, last to last lecture. Yesterday was a presentation. There was a presentation by Mr. Dheeraj Kumar Singh, and before yesterday we have done learning multiple classes, and just you have to just look it and go through it, and we will. Okay, here the focus of machine learning is a supervised classification, and here this is an example of a supervised classification. And we are currently doing the supervised classification topic and supervised learning. And under this part, there is a supervised learning in learning is there. Here you can see that uh, here we have to just this is a satellite image, and first we have to acquire the satellite image, and we have to train that image. We have to select the multiple samples. Here we have select the multiple samples and label accordingly. Here we have taken the blue color for water, and we have select the multiple samples are there. And we before yesterday we have covered all this part, and there is a urban area is here, grass area, forest area, and then we will execute the supervised classifier on this, and which can be SVM or KNN, etc. And at the after the classification, you will get an image uh, which is uh, which is actual classified image. You will not see such kind of a variations here like this one. Here you can see that this is a mountain. In actually, this is a mountain, and there are multiple colors are there. But once it will classified, then it will visualize as a barren land or a soil. So a very important term in this topic, a computer system learns from the data. Yes, uh, which actually represents the past experience. So you have to remember this point, and this is a concept which is actually machine learning is using, and this is a recap towards the learning from learning a class from multiple examples where we have taken the example of a family car. There are positive examples are there for the family car. There are negative examples are there for all other cars, and there is a binary classification is there. And this is a graph which represents the positive examples and negative examples. And class is there. Then there is a false and false positive and the false negative, and at the end we will get the margin and the doubt. And yes, there is another topic we have covered before yesterday, that is the learning from the multiple classes. In the previous case, we have covered the family car, which includes the positive examples as well as the negative examples. So means only uh, two classes are there: family car or non-family car. And here we have three classes, which includes the family car, luxury sedan, and luxury cars and sports cars are there, which is represented by the different symbols. Okay. Uh, then there is some cases we have learnt about that. There is some area which doesn't belongs to the any class. For example, if there is a case which exists at a question mark position, and here there is a rejected region. Basically, we called it as a rejected regions when there is a no or more than one class is chosen. And the this one is a case of a when there is a no class is there, and this is a more than one class category when here there is a this case existing here. And then learning from the multiple classes, here you can just see the comparison between the learning multiple classes and the learning a class, and how the equations is changing with respect to the multiple class. And this is a very similar point here, you can check it out. And there is a difference arises at this point where r, and in this case we have only one class category, so we can say it as a x as a positive example or a negative example. But yes, here we have a multiple class categories, so we have to check it out for the different class categories. And and correspondingly there are hypotheses and the total empirical error is there. And then we have done such kind of examples, and here this is the example of a binary classification, same as a car and family car and non-family car. And in another case we have a more than uh, two class categories, which includes here you can just take it as an example as a luxury car, sports car, and the family car. So we can also convert the multi-class into the multi-class classification into the binary class classification. How we can do it? We can just similarly, and we can say it as a the green. There is a green triangles are there, and we can rest termed as a non-green. Rest known as a non-green. And here we can say it as a this graph. We can say it as a there is a blue circles and non-blue circles, and another one is there which is which represents the red crosses and the non-red crosses. So we can easily convert the multi-class classification into the binary classification, but it is noted that we can't convert the binary classification into the multi-class classification. Hopefully this concept is very clear to you. And this is a very interesting part or application of classification, where you I have taken the two images. There is a date one image and date two image. Then we have just subtract these two images. When we are doing the subtracting, we are actually uh, uh, just this is a, for example, this is a date one image and this is a date two image, and we are doing for each and every pixel of an image. And at the end we will get the difference images there, then which will help to generate the binary classification. And here we have a multi-class here. And again we will do the same process here. We will subtract these two, sorry, not subtract, we will use these two images. We will just represent the date one, and we will just add up with the date two. But yes, we are considering the multiple bands, not we are actually uh, summing up the each and every pixel. And you have to remember it, at the end we will get the multi-class image, and after superimposing this image onto this, we will get this kind of image. and after some rectifications, we will get the classified image. So this is the ultimate target of an uh, target of the machine learning. So this is one of the quite useful information for us. How much change has been happened between the or from date one to the date two. So there are a lot of applications of this kind of uh, this kind of a process, and which is used to identify the how much vegetation area is converting into the urban land or any other. There is a how much the land is degrading or land is improving. That all concept we can do it with the help of this concept. This is a very simple concept, but yes, it involves multiple algorithms in between that. Here we are easily saying that this is a converting into the binary classification, and this is we are just superimposing each and every image. So each and every step there are a lot of algorithms are there, and we are using the different classifiers for that. So this is a we have done it. And this is the parametric and the non-parametric. Yes, actually the parametric algorithms are also known as the unsupervised classifiers. And I'm just explaining this to you because you have to remember this term. This is a just alternate name of unsupervised classifier. And here you can see that Robert, which doesn't require any training data to to identify the things. And here you can see that there is a non-parametric algorithms are there where we can say it as a supervised classifier, which training a robot is trained with the help of our books. So that is one of the concept you have to remember it. What is the difference between parametric and non-parametric? And we have already covered these points. How why it is simpler, faster, and there is less data is required, and there is a limited complexity. This is the only problem with the unsupervised classifier, and the results are not much accurate as compared to the non-parametric algorithms. So, however, there is some pros and cons also in the non-parametric algorithm. There is a flexibility and performance is there, but definitely it is a slower, more data is required, and the overfitting problem is there. And why this is a slower and the more data is required? Because we need a training data. Here you can see that we need a training data, and which consumes a lot of time. And so there is a yes, overfitting is there. Overfitting problem that we will discuss in the with the help of an example. And we can also say that overfitting problem is also known as a overclassification. So this is a type of a non-parametric or a supervised classifier. This is a KNN. It is introduced in 1950s and become more popular due to the increment in computer power, and it is widely used for the recognitions and statistical estimation. So these are the some advantages and why we are requiring it. And, why would we require this for pattern recognition and the statistical estimation? And the next, this is just a brief introduction to the uh, some preliminary steps towards the nearest neighbor. And yes, this will I will explain with the help of example. And, okay, just you have to remember this point. This is one of the most important related to the nearest neighbor. It uses the clay. It uses the k closest point or nearest neighbor for performing the classification. So it is basically finding the closest point, and as well as the there is how many numbers or how many points are there within a boundary. So that concept you have to remember it, but I will explain in upcoming slides. And this example I have already explained you in the previous presentation. If you have any problem in this table, then you can just please check it out my previous lecture. And uh, okay, yes, there is a training data is there. briefly I will explain this point. In this case, we need a very brief information. Uh, for example, the A. Uh, okay, I will take another example. For example, we have a previously we have explained with the help of a car example, and here we will take the example. One second. We will take the example of a duck case. Yes. Yes. One second. I have to just. Okay. Yes. This is a example of a duck, and yes, there are two features of a duck. And what are those features? That is a it's quack like a duck, and it walks like a duck. So there are 2 points. There are two existing features of a duck is stored in the database. So it's like a walk and quack. So this is it's a walk and quacking style is there, and there is some shape. You can also put another feature into it. That is a shape. If it is all are matching, then we can say it as a. We can say it as a duck. So this is some pre-existing databases already available in the algorithm, so we can easily guess the outputs. So this is a here we have already explained. We have already covered this point. This is our test record, and we have to check it through with the help of a pre-existing database. Here, this one is a pre-existing database, and here just find out the choose the okay. Leave it this point. Don't consider this point. And here it will just take the different or check the different features, and here these features are matching with each other, and here you can see that the blue one, yes, the blue one features are matching and these are not matching. Fine, and then at the end we can say it as a this is a duck, and this is a nearest neighbor classifier, and this is the actual working of a nearest neighbor, and it sets the story codes as we have already uh, this is a set of records, and that's why it is saying that this is a set of records, and we have to calculate the distance metric to compute the distance between the records. We have to compute the distance between the this is the test record is there, and we have to compute the difference, compute the distance from the existing database, and then there is a value of k. Yes, this is one of the most important feature of the KNN. There is a k nearest neighborhood that we have already done some glimpse of a k, but yes, we will do it with more practical examples today. And to classify there is the same thing that what we have explained, and this is just you have to consider it here, taking the majority votes. So, for example, there is an example in which there is an unknown record is there, which is represented by the red circle dot, and here you can see that. Yes, there is an unknown record is there, and here you can check it out. And yes, and there are only two possibilities are there. This one is a blue one is there, and there is a red one is there. Red submission sign is there, and here you can see that this one is a circle. We just have to uh, select the area of this circle, and the area of this circle is actually referred to as a K. That's why it is called as a KNN. That is one of the most important concepts. Why we called it as a K? Because we have to identify the boundary, how many samples can be included to know the unknown record. So this one is an unknown record, and according to this circle, this unknown record is actually belongs to the this red symbol. So this one is a positive symbol, belongs to the positive symbol, and then we can say it as a this one is a positive. So this we have also done this part. This is a there is a one. This is a actually k. This is a when k is one. when k is 1, and this is when k is 2, and in this case when k is 3. And yes, here you can see that there is a boundary there, and in which only one training sample has been considered. And in the when k is 2, there are two samples, training samples have been considered to identify the x. Here we have used the only one training sample to identify the x. And in a third case, when k is 3, three we are using the three training samples to find out what is the actual value of x. Now here you can check it out the difference. When we are selecting the value of k, and yes, and it is noted that the k value is actually provided by the user. So when the value of k is 1, then your result is minus. Okay, and when you are providing k is 3, here you can check it out. K is 3. Then you will get the result positive. And you have to remember this point when you are taking the k is 1, then the minus is there, your resultant output is minus, and when you are selecting the value of k is 3, then your resultant is positive. So it is again it's a question mark. How we can say it as a is it a positive or a negative? That actually we need to do the some validation part. Which one is the correct? So we have discussed these two cases. That is when k is 1 and k is 3. Now, but in case of a k is 2, they both are existing. The minus existing as well as the plus is existing. So there is a big problem in this case. Yeah, this is one of the again there is a problem in the KNN, and in order to avoid such kind of problems, problems, you have to choose the value of 1, 3, 5, 7, 9, means you have to select the odd numbers, so that at least you will get into the some result. That is another part. Is it a correct or incorrect? But we need to select a value of k in such a form that we will get the result. At least we will get the result. Okay, and at the end we will identify that which one is the correct or incorrect. That is another part. So, and this is one of the most important point. You have to remember it. Uh, Whenever you are selecting the value of k, you have just select the odd number of odd numbers. Fine. Uh, Hopefully this concept is clear to you. And if this concept is clear to you, then there is no any problem in a KNN. And let's do the next part, and how we calculate the distance. Here there is an axis there, and how we calculate the distance. Yes, how we calculate the distance between x and this plus and x and this minus. And there are three methods are there. So you can use any one of them. But yes, the results may be vary with respect to these equations. But yes, this is the area of research. You can check it out, what the performance of each and every distance algorithm, how it works on a KNN. And here we have just take the two examples. We have just initialized the data, and then we have compute the distance, and here we have just compute the distance with the neighbor pixels. That is the first neighbor pixel, that is the second neighbor pixel, that is a third neighbor pixel is there, and we have a fourth neighbor pixel is there, that is a fifth is there, and the sixth is there. So next point is that what you have selected, you have selected the value of k is 3. So according to that, only the distance which is computed for these this one, this and this will be considered, and this the distance computed from these points will be discarded. So according to these 3 points, these are the nearest. These 3 pixels are the nearest, and these three training data set have been considered. And according to this, what is uh, the question mark is actually belongs to the triangle or star. And according to this example, definitely it belongs to the triangle. There is a green triangle, not to the star. Fine. And hopefully this concept is clear to you all. And yes, please, and it is also noted that if we put the value of k is 5, how it is working. And once we have selected the value of k is 5, then definitely it will include two more pixels, not two pixels, but it will include two training sets. Yeah, for example, it has included these two pixels. So again, in this case, your question mark definitely belongs to the no, not in, it is a little bit different. You will get the star. So there is a difference between the uh, K3 and K5, and what value you have to select. There is again a very big question mark, and that because your entire output accuracy is actually depend on the selection of the value of these two ranges between the 3 to 5. Yes, and that's a good way. You have not selected the fourth, because you select the fourth, there may be possibility you will not get any result for that, and you will get automatically there is an error in an algorithm. So avoid that problem. And yes, there is a big question is that how we can select the value of the k, and actually we can't guess the value of a k. Just please wait for a second. Yes. Next, yes, was selection of a k, and in this case, how you can select the value of k? We can't guess the value of k. That is a very definite answer. But yes, while you are selecting the value of a k, it must not be so small and it must not be so large. So that is the best way to select the uh, value of k. And here we have maybe we have discussed this point. And if I will here we have select the value of k. In this case, there is around 18 or 21 around. There is approximation only. There is approximation, and yes, what will happen according to this? If I will select the value of a k is 21, and why I have put the 21, because I am assuming that there are 21 plus and minus are there, and you can just change it as if there is a requirement. Yes, if I will change the value, according to the value of k, when we put the 21, we will get the result minus, and that is a very definite. Here you can see that the minus, there is a blue one. Blue minus are too large as compared to the red summations. So yes, if I will select the value of k is 5, if I will select the value of k 5, then I will get into the result. The result is positive. There is a definite. So the both results are varying. So according to me, your value never be there is a like 21 in this case only. In this case, your value must not be 21, and it is must not be 5. So it must vary between the 5 to 21, and you can say it as a you can take the 7, 9, uh, 7, 9, 11, 13, or whatever. Because we have a training data set which includes the approximate 20 or 30 samples are there. So if there are 20, 30 training samples are there, then you can select the value of k as a 7 or 9 according to me. But if you have a limited samples are there, and here we can check it here. If there are very limited samples are there, then we can just easily count it as a 1, 2, 3, 4, 5, 6, 7. There is 7 stars are there. 1, 2, 3, 4, 5, 6, 7, 8, and 8 triangles are there. So there are total around 15, and there is a total 15 samples are there. Then in this case we can select the value of k around 5, around 7. Yeah, this is a best way to select the value of k. So, but it is noted that it varies from person to person, and from dataset to dataset. And previously, hopefully, you have attended the lecture where you have learned about how the satellite images are working how the machine learning algorithms are working on a satellite images. And so it basically varies from the data to data. If there is a medical images there, then you have to consider some different parameters, or you have to consider some different value of a k. And hopefully this concept is clear to you all. Then if there is any question, then please write it on a chat box. Otherwise I will proceed further. Okay, then I will proceed further. Okay, this is a simplest algorithm for the k-mean, and I have already told you about these points. That is, first we have to select the value of k. While selecting the value of k, you have to remember only 2 points. The first point is that you have to select the odd numbers, like 1, 3, 5, 7, etc. Second, your number of k's not be higher, not be lower. So, not be like 1 or 3, and not be higher as 19 and 21. So, you have to remember these 2 points. And then you have to, not you have to, the algorithm have to compute the distance between the input samples and the training samples. Yes, this is the input unknown record, and this is the actual training sample which is existing in the database. And this is the once you have computed the distance, then you have to sort it out, and then you have to consider how many k's you have to consider. And here you have defined, yes, definitely here you have defined the k, and then apply the simply majority and end the program. How this algorithm will work? Let us do with some example, and these advantages and disadvantages, and hopefully you all are I have covered this point yesterday, but hopefully you will understand these points. And once you get through the entire algorithm, you can easily guess what are the advantages and disadvantages of this algorithm. Okay, yes. Here, there is an example, and in which you have to select the value of, you have selected a value of k is 3. Yes, and there is a written there. You have to select the value of k uh, as an odd numbers. Okay, fine. And what happen if you will select the even? If you select the even, then there is a problem of class prediction. You may get the uh, same number of the training sample as we have done in this case. Yeah, in second case, here you can see it as a this case when there is one is there and the plus is there. So both are equal number. One is minus and one is plus. So we can't conclude, or we can't come to any decision. Okay, and that's why there is a some instruction is there while selecting the K. And yes, there is an input sample. Yes, input sample, that is a location of the input sample and which you need to put it here. And this is an example of a scared Euclidean distance, and this is a we have to put it here. And yes, now you have to put the input data. And here there is a one variable is there, that is which is you can consider it as a assay durability, and another one is the strength, and you can also take any other example if you want. And here I'm putting the value, there is a 7 is there, we are putting the same values, and you can just check it out. There is once you have put the 7, then this is a one second, this is a 7 and this is a 4. Now here you will get the 25, and here you get the 16 and 3 and 4. Again, there is a 3 is there and 4 is there, and you will get 9, and 1 is there, 4 is there, 1 and 4. Then you will get 13. So, but yes, see here we have written there is a 3, but we have calculated the value for 4. And in the initial stage, you no need to bother about it, and we will put the definitely we will put the value of K. But yes, these 4 records are nearest to the input sample. So that's why we have computed the distance for all the input for all the training samples. Yes, Himanshu Kapoor. And hopefully this point is clear to you all. And the third step is there when you have to, okay, third step is there, you have to sort the distance and determine the nearest neighbor based on the kth minimum distance. So you can just rank it here. There is a which is nearest first according to the distance. And this one you can assume it as a this is a dead, or you can consider it as a radius or diameter. And here you can check it out. You have to make it to the increasing order. There is a first one is there because this is the smallest distance, and that got the maximum rank. And the second one, which one is second? This one is second, and this one is third, and this one is fourth. So you have just put it the rank here like that. And if you have selected the value of K is 3, then definitely the fourth will automatically discard it. So only the first 3 will be included. So this is a sort the distance and determine the nearest neighbor based on the kth minimum distance. Now, okay, this one is already discarded, so you no need to bother about it. And you have to just compare these 3 cases. If I will ask you which one is a bad and which one is a good, then you can easily term as the last one is a bad, but yes, these two values are good. And by, for example, there is a for example, this one is belongs to the minus, and this one is belong to the minus, and but this one is belongs to the plus. So the majority is of minuses. So we can say it as a this one is a good, and this one is good, and this one is a bad. Now, symbol the last time that we have already done this part. You can simply apply the majority. There are 2 goods are there. There are 2 goods are there and 1 bad is there. Then we can simply this pixel belongs to the or the unknown record or unknown pixel belongs to the this category, this good category, and we can conclude at a result. So when at a position of the an unknown record which is located at a position of 3 and 7, it's fall under the good category. So hopefully you will understand this point, which which is very similar to the this flowchart. And hopefully you can do the entire concept with the help of and this example is very easy, and hopefully you can do it with any programming part. There is no any requirement of a Python or any specific language. Even you can do it with the Excel sheet also. So it's a very simple. Uh, if you are expert in doing the mathematical analysis over the Excel sheet, then you can do it on a Microsoft Excel. You no need to be programmer to do the machine learning. So the algorithm is very simple, uh, and the concept is very simple. And at the end, you will get the uh, result. So where we are using the KNN. So again, we are using in a classification here. Classification that I have already explained you. Yes, wait for a second. This one is a classification of the data set. Uh, Here we have take the example of the satellite image, but make sure that we can also do it on our digital images, whatever we can take it from our digital camera. Mm, yes, used to get the okay, missing values. Yes, definitely. You will do it to get the, if there is a graph is there, if there is a process is there, then you can find it over here. What are the missing number is there? You can do it on a pattern recognition. You can do it on a chain expression. You can also do it for the different applications. There are a lot of applications out there. Yes. Now there is a question is, if there is any question, then uh, you can please ask on a chat box, or if you don't have any question, then you can simply okay. First, you have to ask the question. This link is still inactive. I just have to activate these two links. And if you have any question, then please write it on a chat box because the KNN is a very important. Yes, Aarti is asking, we have calculated the four distances. If the value is, if the value of k is 3. Yes, Aarti, this is a very good question. Uh, and here you can see that. Yeah, I will explain. Just wait for a moment. Uh, yes, Aarti, here you can see it. Here the unknown record is there, and once I have to select the different marker. Yes, here the question is there. You have to classify this pixel. This pixel, is it belongs to the triangle or is it belongs to the star? So initially we have to select the distance. We have to compute the distance for each and every pixel which is near to or which is near to this question mark. We have calculated the distance for this one. We have also calculated for this one, this one, this one, and this one. So how many we have computed the distance for the six, but in actual we have selected the value of k is 3. So only these three will be considered. Nearest distance will be considered, and the rest all are discarded. So that is a first we have to compute the distance, then we have to perform the k, because once we get the knowledge about the distance which is near to the unknown record, then we can easily sort it out which of three fall under this category. Here there is a, actually here we are doing the, yes, you can see it as a, here we are doing the graphical, but in actual the computer doesn't understand the graphical. it all belongs to the positions. And in order to compute the position between these two values, these two, then we need some algorithms which compute the distance, and then we have to rank it. Hopefully, Aarti, you will get your answer. And if still there is any query, then you can please write it on a chat box. If it is okay, then also please confirm it on a chat box. And rest all the students uh, can open these two links, and these two links are active for next 10 minutes. And yes, it is also noted that uh, some of you have attended the yesterday class, but you have not marked on a Google form that I have already told you via WhatsApp group. And now you can also put your attendance for yesterday also if you have not filled. If you have filled for the yesterday, you no need to uh, fill the form for the yesterday attendance, because we already have has the record, and we are doing this so that you will get the information we like. Yes, please. If there is any question, please write it on our chat box. Uh, and once you have filled these two links, you can leave the session. You can first confirm me you have filled this, then you can leave the session. These two links are active for next 10 minutes only. Okay, fine. Aryan, you can leave the session if you doesn't have any question to ask. If you have any query, then you can ask me. Otherwise, all the students who have filled the form and marked their attendance, they can leave the session. Sir, please copy. Okay, fine. Aarti, sorry if I have not yet. Okay. Okay, Aarti. Okay, fine. You all can leave the session who have marked their attendance.